Illustrative Math, Geometry, Unit 1, Lesson 4 is called Construction Techniques Number 2, Equilateral Triangles. Okay, so our goals today are I can define and construct an equilateral triangle using a compass and a straight edge. I can identify congruent segments and figures and explain why they are congruent. And our third goal is I can define and construct a regular hexagon that is inscribed inside a circle. A little bit of vocabulary there. First word that you got to know is an equilateral triangle. It's a three-sided shape, or a better word would be polygon, because that's more of a geometry word, where all sides are of equal length and all interior angles are equal, each measuring 60 degrees. So if you look here at this picture here, that is an equilateral triangle there. So that way you know what it is. A regular hexagon is a six-sided shape or polygon where all sides are of equal length and all interior angles are equal. So each interior angle here measures 120 degrees. Regular hexagon can be divided into 6 equilateral triangles. So if I take a straight edge here and draw my 6 equilateral triangles, you'll see that they all look same as this. Okay, all 60-degree angles, all 3 sides are the same length. Okay, but regular hexagon. So an equilateral triangle is also what we would call a regular triangle. Okay, regular means same angles, same side length for the polygon. Okay, so regular hexagon, equilateral triangle, which is basically a regular triangle, but we don't call it a regular triangle, we call it equilateral. Let's see here, let me delete these. All right. Last thing is inscribed. When a shape is inscribed in another shape, all the vertices of the inscribed shape touch the boundary of the larger shape. Usually we inscribe it in a circle, but it doesn't have to be inside a circle. So for example, an equilateral triangle inscribed in a circle has all 3 of its vertices on the circle circumference. So here's that first one right here. Okay. Similarly, a regular hexagon inscribed in a circle has all 6 of its vertices on the circle circumference. Okay. Not every figure can be inscribed in a circle, but a lot of them can. All right, this is from the book. This is the warm-up. It's the same picture. I changed the question. It was normally like a notice and wonder, but I don't know. I didn't really think that it was that good. I thought it would be easier if I just said, can you find an equilateral triangle or a regular hexagon inside this image by connecting intersection points of the circles? So let me get a color here for this. So here is an equilateral triangle. Okay, I might have another one maybe like over here. Okay, there's a lot of them. This one right here might be an equilateral triangle. Okay, there's a bunch from there. See how many you could find? There's another one actually right here. Okay, there's one, or maybe right here. Okay, and then there's one other one there. That would be, is that it? No, I think that's it actually. So there's those. Here's your regular hexagon. There's actually only one regular hexagon inside here. And there it is, okay? So this figure here, it's a bunch of circles, okay? So we're going to use this figure to construct equilateral triangles and equilateral or regular hexagons. I guess it's equilateral, but it's also called a regular hexagon. Okay, here's our steps for constructing an equilateral triangle. We actually have two methods here. We have method one, which we're going to do right now, and then we're going to go to method two after this. So you start with the segment. Now, if they don't give you a segment, if you have a piece of paper, start by making a point, make another point, and connecting them. Okay, that's how you would start. Okay, but I'm going to give you the segment. All right, step one. Construct a circle centered at A with radius AB. All right, let's get my protractor here. Centered at A with radius AB. There's my circle. Construct a circle centered at B with radius AB. So I'm going to keep my compass the same. I'm not going to move the length because so I don't have to remeasure it. Put the center at B. Construct that circle. See how my radius right here is AB? Okay. Mark and label one of the intersection points C. So either intersection point. I'll go up here. I'll call this point here C. So this is similar. Yesterday we did or in the last lesson, we did a perpendicular bisector where we marked both these points and drew a line or constructed a line right there. Today, we're going to just connect these points here, construct segment AC and BC, and we already had AB. Okay, so now triangle ABC is equilateral because circle A and circle B are congruent. We know they're congruent because they share radius AB, and AC and AB are radii of circle A and circle B. Okay? Easiest way to construct an equilateral triangle, just make two circles with the same radius of that segment and then mark the intersection and connect them. Okay? You could make your triangle down here as well. That would be the same thing. All right, here's the second method. Draw a circle centered at A with radius AB. So kind of the same thing that we did before. All right, there's my center. There's my circle. Step one is done. Draw a circle centered at B with radius AB. Same radius. Oh, I moved my compass. Now I got to remeasure it. Darn it. Actually, you know what? I could just go back. There we go. Now you can see that it has a radius of AB. All right, there's that. Step two done. Draw a circle centered at C. Oh, label this point C. So this circle. Label, I should change it. Label and intersection point C. So keep my compass right there. I'm going to call this C. Draw a circle centered at C with radius AB. So I go to C, draw a circle. Now here's the trick. I actually don't need the whole circle. I just need to know where it intersects that circle. So I'm going to just make it a little bit easier on myself, and I'm just going to mark it. Label this point D. So I'm not going to, I should have said label an intersection point. And then I'm going to do the same thing, center to D. And again, I just need to find the intersection point and label this as E. Keep the same radius. Don't let your compass slip. If you got to go back and remeasure your segment, measure your segment, find that intersection point, call that F. This is E. This is F. Put it right there. Oh shoot, that's a problem because it's off up here. So I'm going to move this down so I got my compass there. It should come back right to that point where it intersected. So I'm going to call that G. Okay. Construct segments BD. So let's do that. BD. Let me get a different color here. I'll go with orange. BD. DF. And FB. All right, I guess I should have labeled that point as well. But there it is. Look at that. It's equilateral. Looks like 60-degree angles. Looks like all the sides are the same length. There you go. Now, the next step is a regular hexagon. It's almost everything is the same that I just did with the equilateral triangle. I'm going to do everything the same here. I'm going to just do this. I'm going to get rid of my, see if I can get it. There we go. Get rid of my triangle. And all I'm going to do here is I'm going to connect each point next to the point that's next to it. So, you know, C and D, D and E, E and F, F and G, G and B, B and C. And there you go. Look at that. It's a pretty perfect regular hexagon. Okay. So here's your steps. If you want to write these down, go for it. But it's basically the same thing as the second method for the equilateral triangle. So I'm not going to like do it on this slide here, but you see how it works. Okay. So that's it for this lesson. Hopefully you enjoyed it. Hopefully you got these construction techniques down. You can practice as much as you want. Take your compass, take your straight edge. Just start with a segment and follow those steps. Draw a segment and continue practicing over and over again until you can do it for any segment. Okay. Thanks for watching this video, and we'll see you next time.